on day 4 for the climate change in urbanization. In the past sessions, we've gone through multiple discussions on local and global climate change scenarios with hands-on workshops. Sessions were conducted by expert Professor Rafiq Ham, local faculty expert Dr. Surbi Merota, academicians Professor Subhi Mosh and Dr. Vikunya, and practitioner Dr. Today, we are for a lecture from Professor Hamdi on adaptation and mitigation strategy, followed by Dr. Mehrotra on local climate zone classification system for identifying microclimate at urban scale, and Mr. Saransh Bajpai on assessing the mitigation potential of urban areas in India. With this, I would now address Professor.
Thank you very much for the introduction and good morning, everyone. So as it has been introduced, I will talk about the adaptation and the main adaptation and mitigation using solar power. I will give you an example. Can I change this slide? You will do the, okay. So, next slide, please. So, first, as I said, there has been some slides that I did not discuss with you, and so I will start first by taking what is this information from the latest report. So we will start by this, and then we will go to have some practical questions to how to do the mitigation and the adaptation. So first, I extracted the information of, you remember, in the lecture of the third lecture, I show you what has been the information from the latest report from working group 1, 2, 3, that we focus mainly on the, how the urban island will change in the future, and etc. But here, I extracted the information on adaptation and mitigation for next slide, please. Okay. So, what has been deduced from this latest report, the latest report, is that the urban adaptation option will reduce the risk, but it is unusually and inadequate. And there are limits to adaptation in and around urban areas, particularly as warming increase. What does mean this? This means that if there is any delay in concerted global action on urban adaptation, we will miss the rapidly closing window to secure a livable future for all. What does mean this? Means that the report says that for urban area, we can adapt, but we need to act now. If we don't act now, this window here, the window on which we can adapt our cities, will be closing. Why? Because with warming having more and more warming in the future, this window where our action can be effective will be reduced. So if we make any delay, this window will be reduced, and the action and the mitigation action that we will do, it will not have a big effect. For example, in Brussels, what we do, we try to see what impact of green roof and impact of white roof, for example. If we have green roof and white roof, what we found is that this mitigation action is beneficial, but only in the near future. It was around 2040. The efficiency to reduce urban vitality in city is good, but then when you go to far future, this mitigation option was not enough, because the warming is that big that even your adaptation that you will do will not have any beneficial effect. So that's why this is what the report says, that you need to do the urban adaptation, you need to do it now. You need to have action now for your city. If not, these windows on which you can have still some efficacy, it will close. urban and infrastructure system transition can be accelerated by implementing feasible adaptation option and making it strong synergy with mitigation. So we need to think of adaptation, of action that benefit for both adaptation and mitigation. And I will give you, for example, one. This has been the work of my colleague and my friend Ansar. I'm from Kolkata University. We work on if we put solar panel cities. So solar panel, okay, we will reduce the CO2 emission, right? So we will not, so we will use renewable energy for solar, using solar panel. But if solar panel can impact the urban climate, the local urban climate, this was the question. And I will show you that it impacts, in fact, the urban climate. So this was a recent paper in Nature Cities. So, but we need to think, always we need to think of action that can affect both adaptation and mitigation, if possible. So urban and regional planning that promote compact urbanization and protect ecosystems. So from this report, we say that it's better to go for compact city in the future. Because compact city, if you have compact city, you can say that compact city, you will have more heat island because it's compact city. So maybe but the problem is that you need to think in a systemic way. Because if it's compact, you will reduce CO2 emission. Because if your city is compact, you will reduce the transport emission, you will reduce a lot of things. So so you need to think of for different sectors, not only for one sector. So you need to think in systemic way. So this is what has been said in the report, is that we need to think of the urban system. It's very difficult, I know. You need to take different sectors into account in order to see how you would like to build your city. And we will have some concrete questions that we will have. So, upgrading informal settlement by investing in accessible climate resilient infrastructure and locally relevant ecosystem-based adaptation option and nature-based solution. So we need to think of using nature-based solutions in cities. For example, the greening of cities, we need to think of the species, of the plant species that you would like to put in your city. And you need also to think of, do you need irrigation for this? So it depends on your cities. Are you in an area? So if you put vegetation green in the roof, and there is not enough water, it will die. So you need to think of, do I need irrigation for this? So maybe I need to use some species which are local species, so which are already adapted. So all these questions you need to think of this. But we need to use this nature-based solution option. Social infrastructure and services such as health, education, social safety net, and climate services, and also for disaster management. So we need to take all this into account. So I just talked about greening. So the climate change battle will be won or lost in cities. And from this report, we know that feasible and effective adaptation and mitigation options exist. So you go to the market, we have these options, and they are being implemented, but we need to accelerate the action and target particular vulnerable places and people such as the slum, for example, and invest in hybrid solutions with multiple co-benefits. So for example, you think of, okay, I will put some green roofs or more vegetation, but you need to think of pollution. Is this vegetation that I am adding to the city, is it affecting the pollution? Maybe it will increase the pollution or it will increase the allergy. You have some people who are allergic to some type of species in cities. So you need to think, I told you, in systemic way. Okay? So, I was just talking about the growing of the city. So we have the trade-off. We need to think of trade-off between mitigation and adaptation, and this needs to be balanced. So there is, as I told you, we need to think both mitigation, adaptation, and always there is a compromise. There is a trade-off that we need to take into account. So maybe increasing urban density can reduce the travel demand, as I told you. So if your city is compact, the travel will be decreased, and hence the emission. But you increase the vulnerability to heat wave and flooding, of course. So you will reduce the CO2 from the transport, but if your city is compact, then your heat island will be big. It will increase the heat island, and if you have heat wave, of course, and if you have a flooding, it will affect a lot because your city is concentrated. right? So urban electrification powered by hydropower, biofuel, and nuclear sources can impact aquatic, coastal, and marine ecosystem. And I just give you the example of using solar panel. You can put solar panel. I will give you an example on Kolkata. We simulate this, you will see that it impacts the city also. So you need to think in a systemic way. So climate resilient development combines climate adaptation strategy, mitigation action, and pathways to support the sustainable development for everyone. What is saying this? It means that when we are making this action for mitigation adaptation, and I know tomorrow you will have this exercise with Professor Surapi of making this to think, so you will work by group to work on this, to talk and to see how you could adapt your city. There is always the fact that, yes, here, a pathway to support sustainable for everyone. You need to think for everyone. So no one should be left behind. So you need to think of, and particularly for the vulnerable people. So this you should not forget, and no one should be left behind. What he's saying here is that current climate adaptation is often short-term and associated with specific project or discrete action. But adaptation expands into climate resilient development when it connects to sustainable development and mitigation. Takes a longer time horizon and involving different stakeholders to accelerate transformational change. What is the saying is that, for example, we are very used, all of us, to check the weather, right? If you would like to go this weekend or somewhere, I will check the weather and I will see what. The stakeholder should, and also us, we should think in the same way, but not on weather for 3 days, but for climate, for 30 years, for 40 years. The stakeholder should take this information for the adaptation, and it's difficult because it's not, you are not planning for tomorrow or this weekend, you are planning for 30 years. So it's a bit more complicated, but it's the same concept. We should take into account the adaptation, but usually think of long time. So not only the short, because usually adaptation is for short projects. I will try to put vegetation, but it's only related to one project, but it's short in time. Think always and involve stakeholders. We talk about the stakeholders, involve multiple stakeholders. You need at least for the city, the city, different sectors. So don't focus on one. At least have 2, 3 stakeholders in the city, because then you have at least 3 points of view that you need to take into account in the city. It's multiple sectors. So think always of systemic way in the city. Systemic. So the city are key to climate action, and the climate change battle will be one. So I already said, and I think that yes, we need to accelerate action target particularly vulnerable places and people, and invest in hybrid solutions with multiple coping. I already said this. So now I will give you some concrete questions that you need to ask when you are trying to do climate urban adaptation and mitigation. So here, these are the people with whom I am working. Here, so I'm working with Ansar from Kolkata, so the university, Kolkata University. We are working also with Professor Dev from University of Texas, and with all these people here, and also with he's very famous in adaptation and mitigation of cities, mainly adaptation using full roof. So we are working with this network to try to work on global cities, not only focus on Europe or India, but really try to focus on global aspects. So this is our team. And yes, now I will go with you and try to see some concrete questions that you would like. And I think this will help you for tomorrow. We will have this workshop with Professor Surapi you will work together. These are the questions that you will need to address. So why are you trying to cool your city? This is the first question. And this is these are associated questions that we should ask to make the mitigation plan. So first, why I am trying to cool it? I should answer to this question first. So is it because this is the things that everyone is doing? Or Because, for example, if you look to most cities in US and Europe, they are in cold climate. Where, for example, the heating degree day, you know the heating degree day, and of course, you know, and the cooling degree day, and so the heating degree day is much more bigger than the cooling degree day. Okay? And cold fatality are much more higher than heat fatality. Yes, I mean, if you are in colder winter, I give you this example. I give you this example yesterday. So this is in the city of Ghent. You see that in the rural area, we have much more freezing than in the urban area. So the urban is warm, so we have less problem with freezing in the city. So you need to think. So, and I also show you this problem for the buildings, that this ice crystallization, it's much more problem in rural building than in urban building. You see, in urban, we don't have any problem of this crystallization of building. So for us, urban demand is good during the winter. So you actually can have many wintertime benefits. So you need to think always winter, summer. So you need to think this question. So still, maybe the urban heat island is not your friend. In fact, I based this presentation from one lecture that I got from Professor Elie Bouzet from Princeton University, and it really inspired me a lot. So it's mainly based on his presentation. So what is first thing to ask? What is your climate plan? First question. Is your projected hazard going to significantly shift from cold to heat with climate change? Look at extremes, not at average. We need to see the extreme, how the extreme will change, not the average. The extreme will impact the city much more. If you have flooding, if you have heat wave. So think of the extreme and think, what will add climate change to my city? And for this, as I told you, it will be difficult to get this information from global climate models. You need to do downscaling. Global climate model will not see Bhopal. You need to do downscaling. You need to go to higher and higher resolution to see how my climate will change in Bhopal. And from this, so I need to answer this question. So I need to compare summertime and wintertime urban heat island. Which is the strongest? Here I know that, for example, in Bhopal we have a cold island because of the lake. So, and this, it will very much depend on the annual cycle of rainfall and radiation. Of course, if you have, for example, different background climate, the urban heat island is different in winter and in summer, depending on the background climate, depending on how much of precipitation and how much of temperature. And this is very, very important. And Professor Ansar just remembered me this yesterday. He told me we need not to focus a lot on urban heat island, like the difference between urban and rural. We need to consider urban temperature only because how the climate change is affecting, because the cities are more related, or the urban area are more related to sensible heat, because the latent is not that important in urban area. So in urban area you have the sensible heat, but in the rural area you have the latent heat. So it's different process. So it's good to think of the urban heat island, but you should also think, when you are doing adaptation, mitigation, to the absolute urban temperature. You need to see how your temperature in the city will increase, independent of the rural. I told you, yes? Yes?
So, firstly, can you just explain sensible heat and latent heat in terms of how it plays a role in urban temperature and rural temperature?
Yes, thank you. Because maybe I pass very fast on this. So the sensible heat is how much of exchange. So you need to think of heat, of temperature. So the sensible heat is related to the temperature, to the heat. So it's the amount of heat which is exchanged from the surface to the atmosphere. And the latent is the amount of moisture. So it's related to the moisture, to the humidity. So the sensible is to the heat, and then the latent is related to the moisture, the exchange of moisture between the surface and the atmosphere. So it's different. Why the sensible is more important in city? Because in the city you don't have a lot of moisture. So it's more heat which is exchanged. While in the rural area it's the other way. So I have some lecture, but maybe tomorrow I can. So to show you that the energy balance is completely different. That's why I showed you this yesterday from your question. The energy balance
is completely different in urban and in rural. In urban, all the net energy that you get, the net radiation, the energy you get from the sun, so the net radiation is mainly used for sensible. While in the rural area, the main energy that the surface gets is used for latent, there are other fluxes, but these are the main difference. So that's why it's good to think of urban heat island to reduce this, but it's also, don't forget to consider only the urban temperature. It's very important because I told you yesterday, the climate change in my city, in Brussels, in fact, in the future, the urban heat island decreased. I told you this yesterday, decreased because the rural area warmed a little bit more. Not that much, it was 0.25 degrees, so it's not a lot. But don't think of urban heat island because you can be misleading. Because urban heat island it will be decreased in the future with climate change. But this will not affect anything. In fact, we still saw that the heat wave will impact the city much more than the rural area. So don't think always on trying to reduce the urban heat island. Think also of the absolute temperature.
I have another question. You're talking about a compact city. On a city level,
yes.
right? The concerns are basically city level that the more you spread, the more anthropogenic activities increases, transportation increases.
Yes.
But compact city is good where in our country where we have more cooling degree days.
Yes.
But in heating degree days, which is more prevalent in temperate climate, it will affect one major thing, that is individual level solar access.
Yes.
When I was reading about it, solar access, at certain areas, you need to have solar access till certain time of the day. Individual units,
yes.
architectural units, you
yes.
need to have solar access according to the law.
Yes, yes.
But
yes.
in a compact city,
it will be difficult.
It will be
yes.
difficult, and that will increase the heating requirement of individual units.
Yes, yes.
So
it's a compromise. It's a compromise.
Which is going to have a worse effect because energy consumption in this case for heating will increase, but will decrease in anthropogenic activities.
Yes. Well, I cannot answer like in one answer. It depends on the place. It depends on the situation. You need to. But it's a compromise. It's a compromise. You need to do work and to see. Yes, for my city, for example, Bhopal, what is the most efficient? Is it to have a sprawl, maybe, or is it to have compact? And to see if with this law, you have this law that to get the solar radiation. So it depends on the city and on the climate. And I cannot give you one answer that you need to go this direction and not this direction. It will depend on the.
It also depends upon the behavior and social context.
Exactly, behavior. Yeah,
people
definitely.
are drying their clothes on terraces. They need individual units, and they need that sunshine, daylight, and that is behavior aspect,
exactly.
which also should be considered. If you have people would like to live in apartments, then the things will be completely different. Then again, last time also we discussed about sky view factor, how much openness.
Yes.
So that is also related with how much radiation we want,
sure.
and how much wind flow we want in an area. So it is always like it has to be variable and cannot be fixed.
Yes. Okay. So don't forget, don't focus only on the difference. Consider also the absolute urban temperature and how it evolves in the future. So another question, is heating or cooling more expensive and carbon intensive in my city? So yeah, here I don't see the heating. You don't have a problem with heating. So yes. Can you implement summertime heat mitigation that does not reduce wintertime urban heat islands? Another question also that one can ask. So another things, once you answer this first question, another things that you need to answer, which urban heat island exactly I am trying to mitigate? Which one? Because you have different one. So which one is it? So if I took Bhopal, so this is the surface urban heat island, okay? So we have a cold island from the paper of Professor and we found that there is a cold island. So you can consider urban temperature and their difference relative to rural temperature, at the surface, like this paper. But you can consider in the air at 2 meter level, or at higher elevation. Maybe you are interested by higher elevation, also at 50 meter or 100 meter. So, or beneath the surface, you have also impact on the urban, or the difference beneath the surface, because in the underground, there is a difference between the city and the surrounding. Or in your water body, and this is very important and very typically for the city of Bhopal, you have a lake, you have a big lake here. So you have also problem of you can have this, what we call hydrological urban heat island, in the sense that the water, see, during, if you have precipitation and you have surface runoff, okay, this water, it will run off on hot surface and then it will go to the lake. So it will, the surface, the temperature of the water will be higher because it is runoff on warm surfaces. While in the rural area, this is a cold, this is a, so it's not hot surface. So you can have a difference in the temperature of the water between the city and the surrounding. And this is very typical here for Bhopal because you have a lot of lakes, so you need to think of this. So how the urban area surrounding the lakes can affect the temperature of the water of the lake. So it can affect also the quality. So all this should be, so there is different urban heat islands. First thing to, which one I would like to mitigate, okay? So, and also, so if you think of surface urban heat island, it's a much more larger in magnitude and vary drastically in space. And is almost invariably stronger during daytime when solar insolation creates big difference in it. What does mean this? Means that the surface urban heat island, usually we use satellite to study this, the big difference is during the day, not during the night. Yeah. And the one thing is that if you look to the surface urban is very drastic, it changed a lot in space. Look here for Bhopal, you have, it's very heterogeneous, the surface. But if you look to the urban heat island at air temperature, it's much more homogeneous. It's not all homogeneous, it's not flat, the same, but it's not as drastic as the surface. So it's different. So this was for New York. Okay, another is that, yes, this is what I just said. Air urban heat island is smaller, much more homogeneous, okay, than surface urban heat island, and mostly peaks during the night when the urban surface are releasing the stored heat during the day. So surface urban heat island peak during the day, while air, we call it air, but 2 meters, atmospheric urban heat island, it peaks during the night. So it's different peaks. So it's not the same peaks. So they have different impact. Air, urban heat island, usually the most important for cooling demand. So if you are, for the cooling, if you are in the heat, in hot climate, it's mostly the air urban heat island, which is the most important for you because it will impact the cooling. It's not the surface. You don't care about the surface. Okay? So, and also your aquatic system and water quality will be most directly sensitive to your hydrological urban heat island. Very important for Bhopal. So you need to take into account this. And yes, I already showed you this. The fact that during lockdown, when we stop the cars, the air temperature, the urban heat island decrease in late afternoon. So here it's the urban heat island. It's the air urban heat island. Okay. So. Because, this is I already said that hot urban pavement generate warm runoff that make urban streams warmer than their rural counterpart, on average and at maximum. You can look to this paper. And as implication, as with the atmospheric urban heat island, cities create a hydrological urban heat island. So I already explained this. That and you need to mitigate also this impact, because especially for Bhopal, a lot of lakes. So think of this. So another question, where in the city are you aiming to reduce temperature? So which part are you interested? So are you interested in this part, or the part where you have a lot of slab, for example, or you need to think which part of the city I am targeting, okay? So do you want to have an average cooling of 1 degree over the whole city? Are you interested by the whole city? Or is your overheating problem mainly in the urban core, in the old city, for example? Maybe. So it might be an industrial area with a lot of dark roof and parking, not away from the core. So it depends, which part of the city are you targeting? So how variable is the urban heat island in your city? For this, you need to look to satellite data. So is it homogeneous in my city? Is it one part is really very hot spot, and the other part are okay? You need to know. You need to have a spatial information on your city. Where is the problem in my city? Okay, so is it strongest in poorer neighborhood that have little tree cover, like slums, for example? You don't have a lot of trees. So is it strongest in this area or not? We don't know. You need to investigate this. Can we use urban heat island mitigation as a tool for increasing environmental equity? It's a question for inclusiveness. Huh? I told you, no one should be left behind if you would like to do a good adaptation measure. So where are pedestrians most concentrated? Do you want to target this area of pedestrian? Are some area near large water body, which is the case here for Opa? So the lake, the lake breeze, lake land, not lake sea, it's lake land, sorry. Breeze means that they are better off during the day, but maybe worse during the night. So you think you have a lake here, so you will have what we call lake breeze during the day. It's a lake breeze, which is the it's a bit, I am still trying to make the runs, but it's still not working. So I can show you that when you have a lake, you will have some wind which goes from the lake to the surrounding, because, okay, during the day, so it's a breeze. It's like I told you this. So this might impact the surrounding of the, so you need to think of this also, okay? So where are the surface or area you can intervene in? Because there is maybe some place where you can have intervene, you can make action, but maybe some place you cannot. So you need to see which part also that on which you can intervene. Okay? So it means it's still possible to do actions. For example, in Europe, now we focus more on suburban area. Why? Why? Because suburban is still developing. But why in the pure dense we don't have place to do any action? So you need to see where in my city I still have possibility to make action. So now I will show you some tests that we did for Kolkata with Professor Ansar. So it's paper published 2023. So what we did, so is we try to see different options. So here we use cool materials, okay? For Kolkata, so this picture. Then we try the green roofs, the vegetation fraction change, we increase the vegetation. And then D is a cool city and super cool broadband material. I'm not an expert on this, but Ansar is expert on using this material here. And you can see here how it can, so this is the difference of ambient. So it's 2 meter temperature, it's the air temperature. How the air temperature can be reduced, you see, until -2 here in the center of Kolkata city. And this is how it affects the surface temperature, not the air. You see that the surface, you can get much more higher, -4. While the ambient temperature is only -2. So yeah, so and then you can see, okay, if I consider that I can put action on all the city, this is what we'll be doing. Okay.
Sir, what does mean A and E, cool material and super cool product?
I think that cool, yes, this and this one, I think it's a difference in the albedo of the roofs. And you are using some material which have a really high reflectance. So the albedo is mainly about the albedo of this material. I think they are using nano material, something like this, which have a high albedo, a high reflectance. Why? This cool material is like the material that are already in the market that you can use it. But this is like a new super. I am not expert on this too, but these are some really super. Yes. Okay. So another picture here is that, but yes, of course, you need first to check if your model or if your observation is good. So here, this is the urban heat island of Kolkata from observation. So this red here is the mean observation, mean urban heat island. You see, that's why I asked you yesterday for the tutorial to try to plot this, because this is the normal shape of urban heat island. During the night, it should be high and then decrease, and then again high during the night. And so that's why I asked you yesterday to make this, to try to reproduce this shape. But you see in Kolkata is that this is 0. During the day it's negative. So it's a negative urban heat island during the day. So it's different. So you need to take this into account also. While in Brussels, for example, the urban heat island during the day is a little bit higher than 0. It's very weak, but it's not negative. So different things need to be taken. So the urban heat island, yes, the urban heat island, always in this paper of Ansari 2023, we found that this is the sea breeze. So you have here the sea, and then you have Kolkata here, and then you can see that if you put this mitigation, if you put roof, it can impact also how the sea breeze is penetrated into Kolkata. So it's not, so you see that it's not only, it will not impact only the temperature, but it will impact also the local circulation. Like sea breeze here in Kolkata, it is impacted by this mitigation that we have. The same here. Here you have also local circulation from the lake. So you can see, for example, if you put any mitigation option for the Bhopal, how the lake breeze can be affected by the mitigation, this mitigation option. So another question that we need to ask, when time of the day, period, do you want maximum cooling? Which time of the day you are targeting to have maximum of the cooling? Because as I told you, surface and air, urban heat island, they have different diurnal cycles. The surface peaks during the day and air often at night. Which one are you targeting? So which one? Do you want to make the whole summer more pleasant, or do you want to focus on heat wave period? That's also very interesting. In my country, the urban heat island during the summer is okay. We don't care. It's good. During the winter, it's even beneficial. But the problem of urban heat island in my country is during the heat wave. Because during the heat wave, the old people and the people who are vulnerable, during heat wave, and if you are in a city, during heat wave, the heat stress will be much more in city than in the surroundings. So we don't care about summer, normal summer. We care only during the heat wave, because this is where the people are, the mortality and the morbidity and going to hospital, people going to hospital is increasing. So we need to have this question, which one are you focusing on? Is it the mean or is it the extreme? And don't expect consistent results from your mitigation measure every day. The effectiveness of mitigation measure depends on cloudiness, wind, time of the day, antecedent soil moisture, etc. I will give you an example. So you will say, okay, I will put white roof to mitigate my city, but is the white will be still white? It's not sure. Because with all the aerosols and all the dust that will be on it, it will be brown maybe. It will not stay white. So you need to have to maintain this. So it's, well, another thing, can you use irrigation during extreme heat? Can you increase irrigation? So you can think of, okay, during extreme, I can increase the irrigation. If I increase the irrigation, the plant will evaporate more, evapotranspirate, so the plant will transpirate more, and then I will get cooling. But is this correct for your plant during the extreme? Maybe your plant, when it is extreme, they will close the stomata. They will not evaporate. You have some plants which close the stomata, their stomata during the extreme. So you need to think: is it good for me if I increase the irrigation? Maybe it does not. It will not add value to your. Because you will not get more cooling because your plant is stopping the stomata. No transpiration. Okay? So, and yeah, this is just to tell you that this is the urban population. I was talking about the people. So here, this is the urban population which are at risk of extreme heat. And this is today, and this is in the future, 2050. So this is from where we got this data. And you can see that if you look here to India, you can see that a lot of people will have this risk of extreme. So you need to focus on extreme heat for all these people. You see that, for example, in over 1.6 billion people will suffer from this. They will be at risk of extreme heat. So I told you about the future. This is just to show you we need to have information on the future. Okay, and yesterday and the previous lecture, I told you we need to know how the climate change will change in Bhopal, for example, but we need to know what is the uncertainty. Do I need to use different projection or only one? Or this is what we did here. So in this paper, in Communication, Earth and Environment, what we did is that what they did, it's not me, what they did is that they try to see when you have compound, drought, and heat wave. Okay, so we are concentrating on, we are interested by a compound. I told you what is compound. So compound is you have drought, and you have on top of it heat waves. And then if you focus on India here, you can see that if you are interested by this extreme, what is the most important is, so if this is like the uncertainty, is the uncertainty coming from the global climate model, or is it from the scenario? I explain the scenario, different scenario, or is it from the indicator? You can have different indicators for a drought. You can have from the soil moisture, you can have from the hydrological, you can have from the precipitation. So which one are you using? But we use different indicators. They use, not me, but they found that the most important, you see here, 53% is coming from the global climate. What does mean this? Means that in India, if you are interested by this compound extreme, it's better to take as much as possible different global climate models, and not scenario or, so whatever the indicator you will take, it's only 24, is okay. Or whatever one you will take, the big uncertainty is coming from the global climate model. So it's better to use different, to study your city using different global climate model. Because this is the uncertainty, the big uncertainty in the region of India. Okay? So, and it's changing. For example, look here to Mediterranean. You remember I told you in the previous lecture, the Mediterranean basin will suffer a lot. It's hotspot for climate change because it will be more heat, yes, and less precipitation, more drought. You see that in Mediterranean, what is the most important? So we don't care about the GCM, it's the scenario. So it means that whatever global climate model you use, it will give the same projection. So don't worry about using different global climate model. If you can use only one, is enough. The most important is the scenario that will affect this region. But in India, it's not the scenario. Okay? It's mainly the uncertainty is from the global climate. That's also interesting to take into account when you are doing mitigation. Because you need to see in the future, your action, is it still okay also in the future plan? So this, okay, then, what is the timeline over which you want results before, this is just because you know that the election, the stakeholders, they are thinking always of the election. So it's always for 5 years or so. So they are not taking off longer action. So we need to think. How quickly can you get approval and actually implement the mitigation plan? So, because sometimes you have bureaucracy, you have administration, it takes time. And what is the climate change timeline of your city also, which means on which timeline you are interested? Okay, so, yes, another question, what urban solutions are most effective in my city? So this depends on geoclimate. Trees and tall vegetation, should I use short vegetation? Evaporation cooling without vegetation. So depends on which species I need to use. Is it reflective surface, the most important? Is it reducing most heat? The material that store less heat? Which one I need to use for my city? And maybe co-benefits. Maybe I need to use 2 or 3 of them. And also the species. Which species I need to take? I was just in one project last week in Belgium, and this project we try to see is the species in the urban are different. So we take the same species and we put it in the urban environment, and we take the same species and we put it in rural environment. And they make a comparison of these species between the two environments. We found that the same species, but if you put it in an urban environment, it has less stomata. So it's an adaptation of the species in an urban environment, that the same species have less stomata, so it will evaporate less. So you need to take this into account when you are doing adaptation. So here are a different way of doing this adaptation. So you have the baseline scenario. So okay, maybe I don't care. I don't care. I don't need any adaptation for my city. Maybe you need green roofs. Maybe you need novel material, as the paper we did with Ansar using this super cool material. Maybe retroflective facade, smart irrigation also. So to think how I can increase the irrigation during heat waves. Then it will cool, but maybe it will not be effective in use. So you need to think of this. So another paper here also by the team of Professor Han was to see, yeah, this is the super cool material that we use here, okay, for, and then what we found is that it works for one climate, background climate, but it's not working for another background. So here it's, you see that optimal cooling of dry condition with clear sky in Iran. So this type of super cool material, it is working only in dry condition, okay? Because it's in Riyadh, in Saudi Arabia, it's very dry, so this is dry condition and clear sky. So if you have this type of material, it will work only in clear sky condition, dry. But it's not working very good in Kolkata. Why? Because Kolkata you have a lot of water vapor. And this water vapor, what will do, it will reflect. So you have this radiation which are reflected, but if you put the water vapor, you remember from the lecture I told you in the beginning, water vapor, they will reflect this. They will reflect. So the radiation will come back. So we will not be able to reduce. So it depends on the background. So you need to take this into account. And this is the paper, the last paper with Professor Ansar that we did and published in Nature Cities. What we wanted to know, I told you we need to combine between mitigation and adaptation. We try to, okay, we said we will put solar panel on Kolkata. Okay, we put solar panel on all Kolkata, and we wanted to know if we put this, because it's good for the emission, right? So we will decrease the emission, etc. But is this solar panel impacting the urban climate of Kolkata? But we found that it's yes. We found is that photovoltaic solar panel warm up and cool down city. So it will warm up during the day. During the day, we found that it warm up to, you can see here, up to 1.5 degrees the city of Kolkata. But during the night, during the night time, it reduced by 0.6. I will not enter into the process, but just to tell you that using solar panel over one city will not, it will affect also the local climate. Okay?
So it is affect only for the day?
Both, day and night.
It will affect higher, it will increase the temperature?
In the day.
Into day?
Yes, in the day increase by 1.5 Celsius, the air temperature. Yes. But during the night, it decreases a bit by 0.6.
It is not absorbing the roof area. That's why.
No, in fact, what we found is that when you put this solar panel on the roof, the solar panel, they are not, if you have the roof, the solar panel are not like this. The solar panel are always like this.
Yeah.
Okay? And if you have your solar panel like this, you have some air which can go inside. This air which go inside, it gets warm.
Yeah.
Because this surface are warm. You know, the solar panel can go to 70 degrees or more, I think.
Yeah.
So this air warm and then go and for all, and then go up, and this warm during the day to all area. And this is quite new because it's very because before people that study solar panel did not take into account this effect.
Okay.
But this was the first time Professor Ansar and his team, we take into account this effect that you have air which can go inside and which can affect, and so it's the sensible heat again.
Yeah.
I told you in the city, the sensible heat is very important. You should take into account. So that's why we're very happy that it was accepted in Nature. It was in November. Okay, so this is the type of, and then I will finish in.
Okay. Yeah, one.
How
much is the area of impact? The warming of the air
Yes.
around the solar panel.
Yes.
How much is the area of impact around the panel?
We consider here that we put all in the city. 100, all the roofs are with the city. So it's over all the city. So this means it's
That
over.
is a case scenario that.
Yes, it's a case scenario. It's not observation. It's a case scenario with WRF. We use WRF, you know, this WRF is atmospheric one. And we just consider that we put roofs on all the city. Of course, it's not possible because you have some roofs which are like this, but you have other roofs like this. So it's not possible to put all. But it's a simulation. Just to say that we need to take into account that if you put solar panel, you might increase the temperature in your city. But it's a simulation.
One assumption that you have taken is that all roofs have solar panels.
Yes.
There could be another assumptions, many other assumptions also, like the height of the buildings are really
You are right.
are same.
Yes.
If there are high rise and they
Definitely.
also have shading
Definitely.
effect.
So we took different heights. depending on different local climate zones, because different local climate zones have different building heights. But of course, we did not go into the details, like changing the height every one, and we did not take. So it's a simulation where we consider that we can put this on all buildings.
And also the trees.
The trees, of course, yes.
The
yes.
high
It can also
canopy and other shading.
Definitely, yeah, the shading also.
So was this simulated for a particular month?
Hmm?
For a particular month?
This was during the summer, yes.
Okay, so in summers it will have a 0.5 degree increase.
Yes.
And can we understand what is the impact of this during the winters?
What is that?
The same scenario.
Yeah.
In winter, how will it impact?
Winter, no, yeah, we did not make this during the winter, yes. Yes, but it's good, yeah, to see, to answer. Just to tell you, just to give you one example of, we try to combine adaptation and mitigation in the city, but you can have increase of temperature in the city. So if you don't do it, so here the recommendation was that we need to use solar panel which can decrease the heat which is going out. So we call it the efficiency of the solar panel. So it is because solar panel they will use energy. So the solar radiation, one part will go to electricity, but another part it will heat the surface, and this part will go to the air. So if we decrease this part, that's good. This was the recommendation. We are not saying that solar panel is not good. Of course it's good, but we just think of, it will affect, but it's better to work on the efficiency of this. And I will just finish now to tell you that think always you have two processes, urbanization and global warming. Different, of course. With the CO2, the CO2 coming from the urbanization is coming from the global warming. So we need to differ. So what I have in urbanization? I have urban heat island. I have modified precipitation and urban water cycle. I showed you this in the previous lecture. I will modify ecology and biogeochemical cycle. Global warming, what global warming will add to me? It will increase the intensity and duration of heat waves. It will change the precipitation and evaporation pattern. I just showed you. It will change also the hydrometeorological change, will impact ecology and biogeochemical change. So another question, how will this impact interact? So how urban heat islands interact during heat waves? Because heat wave is not due to city. Heat wave is not urban effect. Heat wave is a climate effect. So how the heat wave interact with urban heat island? Maybe it will increase the urban heat island. Maybe it will decrease the urban heat island. So if you look to the difference, but I told you, don't look always to the difference urban. Think to the absolute temperature of maybe during the heat wave, the temperature of the city will increase a lot. Why it will okay in normal summer. So, and will there be positive or negative or no feedback? This is the feedback. Is it a feedback? Is there a feedback between these extremes and urban? Now we are working, I told you, on the impact of compound extreme on city, on urban climate. So this is a really new topic of research. We are working on this in Belgium to try to see, to take into account this interaction. And I think it's finished. Thank you so much.
With this, we would break for tea and come back up.
Now we are working, I told you, on the impact of compound extreme on city, on urban climate. So this is a really new topic of research. We are working on this in Belgium to try to 100. All the roofs are with the city. So ecological change will impact. All the roofs are with the city. So ecological change will impact. With the city. So ecological change will impact. With the city. So ecological change will impact.
today, for the next session, we have Mr. Saransh Bhai with us. I would ask Professor Jyoti Sarup to please felicitate Mr. Saransh Bhai. Mr. Saransh Vajpayee is a distinguished climate change expert currently serving as the Associate Director for the Climate Change Program at World Resources Institute, WRI, India. His work focuses on climate action at state and local levels, advocating for innovative and practical solutions to mitigate and adapt to the impacts of climate change. Mr. Bajpayee holds a master's degree in development and environmental management from Indian Institute of Forest Management, Bhopal, and a bachelor's degree in electronics and communication engineering for JP Institute of Information Technology, University, Noida. Prior to his current role, he was instrumental in revising Madhya Pradesh State Action Plan on climate change, aligning it with emerging climate priorities. His earlier tenure at Department of Environment, Government of Madhya Pradesh provided him with a deep understanding of the challenges and opportunities in climate action. With over a decade of experience, Mr. Bajpayee has made significant contribution to the field of climate science, policy and implementation. His dedication towards advancing climate action and his ability to translate complex scientific concepts into actionable policies have made him a respected figure in the field. I would now invite Mr. Saransh Bajpayee to the podium to address the gathering.
Thank you so much. Good morning, everyone. Is it audible? Is this working?
It's for online.
Oh, okay. Okay.
So do you need mic for louder?
No, I don't think so. I mean, this. So I am very delighted to be here. I would like to thank Dr. Swaroop and Dr. Mehrotra for having me here. It's always a pleasure to speak before young talent, emerging talent, and talking about some of the things which are very relevant in the contemporary times and which are required, by the policymakers. So academic exercises are very important. Without them, you cannot come up with a good analysis. But how to translate that analysis, how to capitalize, make it relevant for the practitioners, for the policymakers, so that you can achieve that real impact is, what is required by the industry, by the government in the current times. So, can I have the presentation, please? Till now, I have been informed that all of you are made aware of the science of climate change, how it impacts the urban areas, how urban areas contribute to the impacts of climate change, what is adaptation all about in the urban context, what is mitigation all about. So I know that I won't have to apprise and inform you about that, but I'll take a step ahead, and my presentation would cover a practical study which has been implemented in a lot of cities and how it has been beneficial to the local stakeholders, as well as what are some of the challenges or those pain points which need to be kept in mind and how to overcome them. So the topic on which I'll be speaking today is assessing the mitigation potential of urban areas in India, a data-driven approach in a data-scarce environment. Now we all understand that having data at the national level is quite easy. There are a lot of, apart from government, I would say non-state actors who hold a lot of data, who carry out these primary surveys, and they have rich quality data. But having the same at a local scale or at the subnational level becomes a bit difficult. That is why a lot of modeling exercises which are done at the global level, Sir has talked about IPCC and its assessments, they are at the regional scale. Now bringing it to the national scale is a challenge. Now further, bringing it at a state level or a region in a country level, that again is a challenge. So downscaling and all those things is the mantra. But then with downscaling, you lose a lot of, essence. So what are the implications for a bottom-up analysis is what I would be covering in my intervention today. This is basically we did a study. We started with a study which was a part of an implementation, and the insights which we got from this study, we documented it in the form of a working paper, which was launched some time back. And we are putting this exercise to use in all the city level work which we are doing as an institute. So, all right. So there are some facts, some data which is presented on this slide, but all the sessions which have happened till now, I think you all must be appreciating the fact that all the evidence on climate change which has been presented till now, it establishes the fact that the battle against climate change, if at all it has to be won, urban areas play a very important role. And why is it so? Because cities globally account for more than 70% of greenhouse gas emissions, which is bound to increase in the future. Why? Because 50% of India's population is likely to live in urban areas. And when that will happen, there will be a huge demand for energy. In the context of Indian cities, there will be a huge demand of energy from the cooling perspective. Because we are a tropical country, we have these impacts of heat waves and heat related stress. So there's a dire need to start planning for climate action from the context of this rising and projected rising GHG emissions. At the same time, climate action at a local level, it's largely ad hoc. Can anybody explain or give an example of this? Why do I say that climate action, whatever action is happening at the city level, it's ad hoc? Maybe an example from the e-bus deployment.
For example, from my campus only, we are installing the permeable paving, but they are first concretizing the surface, and then for the surface only they are putting the permeable paving. But the purpose was to increase the surface, decrease the surface runoff, and increase the permeable space. But that purpose is not solved. So it is ad hoc.
So here, I understand, I appreciate it. So here the issue is not about ad hoc nature of why this permeable surface is being developed at the first instance. There is an issue with the implementation. What I'm saying is that if climate action in cities is happening, that particular thinking is only ad hoc.
I think because we need energy for growth, and any climate action that we take might decrease or charge the energy that we require. So it becomes a major compromise when we talk about climate change requirements than the economic growth that we require.
Right. Anyone else?
Actually, we have not conducted enough studies for the implementation of various schemes. We just started with the idea without understanding the ground reality.
Correct.
And the thing which we use bottom-up approach.
Correct.
So we don't have a grassroots level of planning and requirement. So that's
Right.
why they appears to be
Right. Right. So what he's saying is that, for example, the e-bus program. So the cities are now, because there is a competition which has been created, a call for bids which is there, call for demands so that demand can be aggregated, which is happening at the national level. All the cities are now, based on their economies and their requirements, they are submitting their requirements that we would require 40 e-buses, someone was saying 200 e-buses, etc. But is that based on any planning? Has some data assessment happened? Has some needs assessment happened? Or when you are deploying e-buses, as madam was saying, that what will be the implications on energy use, energy demand? Because the grid is still coal-based, right? So if you are basically what is happening, you are substituting from one fuel to the other. Of course, there will be some reduction in emissions. Tailpipe emissions will also go down, air pollution and all those things would be curtailed in the cities, but then where is the power coming from? So has these kind of assessments happened or not? And that is why it is very necessary to, transform from this ad hoc planning to a data-based planning, data and analysis-based planning. Now, the study which we did, there were two components. One was at the national level, one was at the local level. I'll be talking mostly about the local level because that is more, that will be more interesting and in the context of the program. So the idea was to use city scale data and modeling to set emission reduction targets for the cities in the future scenarios and prioritize mitigation actions. Now what happens is there can be a long bucket list of mitigation actions which anyone can think of. Okay, I want to promote e-buses, I want to install rooftop solar, I want to install ground-mounted solar PV or rooftop solar or anything else for my water pumping, etc. There can be a lot of measures, but which ones are applicable to your city? Which ones will make will have a more impact? So that is where these data-based analysis and setting of future targets based on future scenarios comes in. And this entire exercise was highly consultation driven. It was not a desk exercise. Validations and vetting was a part and parcel of the entire process, which then informed the city level climate action planning. So this is the process which we had adopted. We did this analysis for 4 cities. As you can see, they are very varying in their nature. One is Mumbai, a metropolitan, huge population. There's a floating population as well, high GDP growth rate, a decent level of per capita incomes. Then there's Indore, which has currently low income today, but it is having a higher rate of GDP growth as compared to population growth. So, that is one city. Ujjain, a very small city as far as population is concerned, but has a huge floating population because of the pilgrimage tourism. So we picked these cities. Again, there was an analysis which happened. I'll show it in my next slide. The idea was classifying the cities based on current income. When I said Indore, it is low in income today, but projected economic and population growth, what will be that? So there were some parameters. These were some of the parameters based on which we decided the cities. For data, there's a climate smart cities assessment framework which Government of India has developed. The 3rd round has happened. Every smart city has to participate in that, and now it is being extended to other non-smart cities as well. it basically has 5 thematic areas: energy, transport, water, waste, biodiversity and urban green cover, etc. And then there are indicators in each of these thematic areas based on which cities have to submit their data to the Government of India, and then there is some ranking which is done for each of these cities. So we got hold of this data, as well as we got primary data from the local city authorities as well as parastatal organizations for the purpose of our study. And then there are some tools which are available. The pathways model by C40. We were able to use this only in Mumbai because Mumbai is a C40 city, and pathways is restricted in that way that only those city authorities can use pathways tool which are a signatory to C40. But for the other 3 cities, we used the World Bank's CURB tool. Again, there are limitations with these tools, which I'll be talking about towards the end of my presentation. And finally, based on the scenarios which came out of these tools and models, we proposed certain climate action strategies for each of these sectors. So this was the criteria for selecting the cities. I'm just showing the case of Indore for the purpose of my intervention today, because showing for each city would take a longer period of time. For this analysis, we looked at the current incomes of the city, the future incomes, the GDP growth rate, the current GDP, the future GDP growth rate, and the population growth rate. And based on this, and the point where the axes intersect, that is the national average. So 1.26 and 4.84. X-axis is the income, and y-axis is the proportion of income growth relative to population growth. So Indore, right now, it's an emerging city. This is the classification which we did. We did this for around 14-15 odd cities. Again, why 14-15 odd cities from a list of 4,000 plus cities and towns? Because this is also a data intensive exercise. You do not have GDP figures at the city level available for every city. It's very difficult to get that. So in an emerging city is which has a low income today, but there is a high income growth relative to population growth. That means the economy is economic activity in the city, which is leading to the economy surpassing the population growth. And when we look at this particular decade where Indore is progressing, I think this is the PDF. Anyways, so that there's a transition in this. This green dot in the 2030, it moves somewhere where this Indore 2030 is written. That means that Indore in this particular decade or the decade after will move from the emerging cities category to the stabilizing cities category. What will happen is that because of the current high income growth relative to population growth, it will become a high income country, high income city in the future. So somewhere over here. So basically, Indore will become a high income city because of this factor. And when incomes rise, there is a tendency to move towards equilibrium. So Indore will have a low income growth relative to population. That proportion will gradually keep on reducing. So it will become a stabilizing city. Now what does this mean? This means that if an emerging city today, which is witnessing a high economic growth, so it will invest in infrastructure, right? What policymakers need to ensure that they do not build an infrastructure which locks in carbon. The technology should be such that it doesn't make the city enter into that perpetual cycle of emissions, right? So the technology choice has to be optimized so that when it moves to a high income city, it is able to say that my economic growth has not led to emission growth. So For other cities also similar analysis was done, based on which we selected the cities, and this was also an important criteria to come up with recommendations of which city needs to do what. Some cities, are, there was also a case that there is a thriving city which became an emerging city. Now all this is based on the observed data. So in that case, there are again similar recommendations to Indore, but also preserving the current infrastructure, etc. Those are the recommendations. Now, based on the criteria for used for selecting the cities, for Indore again, we through data collection and data assessment, we came up with this figure, with this graph, where the emissions are currently and where they will be. This is again, projection is based on CAGR. We have a past 10-year greenhouse gas inventory record for Indore. Based on the CAGR, we have projected for future. Now, this is a business as usual emission scenario, that if no new policies come up, no new actions are taken, whatever has been happening in the past decade, that goes on, how will the emissions look like in the coming next 2-3 decades? So what we can see is that there will be a 1.5 times increase in the emissions in the business as usual scenario. Now this is huge. If you look at these figures, they are tons of CO2 equivalent per year, right? When we did this on a per capita basis, we saw that it will be more than 2.8 to 2.9 tons of CO2 equivalent per capita per year, which is way above India's average. Of course, anybody can say that for a city like Indore, this is fine. But then this is our challenge, that we have to reduce the emissions. How can that be done? And if we look at the breakup of these emissions, so the largest category is manufacturing and construction energy. Again, city by city, this would change. This breakup would change depending on the economic activity. But if you see in Indore, and overall if you see, these two sectors, residential and commercial energy and manufacturing and construction energy. So basically energy use emissions contribute to the largest chunk of emissions. So you get a fair bit of idea where actions need to be taken and what kind of actions need to be taken, right? Now we did the modeling of the future scenarios. This was done using Curve tool, again a very data intensive exercise. We collected data, we consulted a lot of stakeholders at the city level, at the state level and at the national level on what the future policies can look like, what future programs and missions could look like. At the local level, what is economically feasible for the city. Matlab, there can be a case where you speak with, say, a CEO of a smart city or a commissioner or a political leader, and they can say that I aspire for a 90% rooftop solar in my city in the next 10 years. But then if you speak with the technical head of the department, he would say that's not economically and financially possible. If you speak with a DISCOM, they would say, no, we cannot do this. What will I do with the coal generated power which I have if you install rooftop solar, right? And then, of course, how will you handle the variability? Because renewable power right now, it is variable in nature. What will you do in night? Do you have the storage capacity? Is there a battery storage or pump storage to that scale available? Does the city, if at all, it thinks that I can go for 90% rooftop solar with storage, does the city have the money to do that? If not, where can the money come from? So all these things, are possible to answer based on this analysis. So this was the first scenario. There's a business as usual scenario which I showed in my previous slide. This is the planned scenario. This is based on the current policies which are there. Now a city normally doesn't have a policy. The policies at the state level and at the national level. Cities, are benefited by these policies at the 2 tiers. And then they have their own set of aspirations. So this scenario was created based on the existing policies at the national level, FAME 2 scheme, and the renewable purchase obligations and all those things. And then what are the policies or enabling provisions at the state level, etc. And what is the planning going on at the city level? So they must have entered into some tenders or floated some tenders to add certain capacity. So considering all those things, then there are comprehensive mobility plans which cities develop. What does that say as far as deploying electric buses is concerned, or transit-oriented development, etc. So all those things for different sectors were incorporated in the existing and planned scenario. And what you can see is that as compared to the business as usual scenario, where the emissions were rising like this, there is a scope for Indore to reduce 40% of that emission. Now these are some of the things which are in pipeline, and based on this the existing and planned scenario was developed. So based on this, if you go to a local decision maker, city level decision maker or practitioner, and you show this to him that, sir/ma'am, this is possible based on the current plans which you have. So this will open their eyes, and this will lead to a sense of motivation that there is something additional which we can do. And this is that additional. This is the achievable scenario. Again, if you see, none of these two scenarios are leading to net zero, right? There is a significant gap remaining even in the aspirational or ambitious scenario. Ambitious scenario kya hai? When we say that in the existing and planned scenario where you have a target to deploy rooftop solar, say 30% of the buildings, both residential, commercial and municipal, will be rooftop solar by 2050. So based on, again, discussions, technical conversations, economic and financial conversations, if they are able to say with conviction that we can increase this target of 30% to say 45 or 50%, it is possible. Conditional, based on we get finance, we get this, we get that, private sector comes in, all those things. It is still possible to achieve 50% rooftop solar. Similarly for other sectors, then what will happen? In that case, Indore has the potential to go from this 40% reduction to 80%, which is huge for any city. If they are able to reduce 80% of their emissions by 2050, it will be a huge achievement. And then if you add up all these for especially the big cities, the 125, 130 smart cities, and then some other cities which are not smart, but then big cities, Amrut cities, etc., it all aggregates to a huge figure. So, and then, India has its obligations under the Paris Agreement. They have to, submit their progress on the NDCs before the next COP. The biennial transparency reports, all the parties have to submit to UNFCCC. That exercise is ongoing, where countries will need to show what is their progress on achieving the NDCs. If this kind of an exercise can happen and start, the BTRs can also be influenced and put India, or for that matter any other country, in that negotiating position. So this is the third scenario which can be developed out of this tool. And this is the breakup of the different activities which the city, in a very consultative and participative process, was able to come up with. That as far as the renewable energy generation is concerned, through rooftop solar and all those things, 60% of the conversions can be made, subject to availability of finance and private sector participation. Percentage of high income residential buildings with rooftop solar, 70%, municipal buildings 90%, Again, they were a bit skeptical in coming up with these targets. Otherwise, municipal buildings can be, why not 100%? Again, because of financial constraints and all those things. Cash flows are a major thing which cities are grappling with. Whatever revenue the city is able to generate, it is mostly being utilized for the recurring expenditure, the salaries, the fuels, all those things. So some of these targets are leading to the mitigation potential in the energy and buildings sector. If we look at the transport, most of the contribution is happening from passenger mode shift. So right now, switching the movement from private vehicles to public transport. That has the highest contribution. And then, of course, transit-oriented development and vehicle fuel switch. So these are some of the levers. Solid waste management, Indore is already doing a lot. There was a very less potential for reduction in emissions. But then, what Indore is not doing, there are a lot of things which can happen in Indore. For instance, they have STPs installed, the sewage treatment plants, but they are not capturing the gas, which is, being emitted, and that is methane. Methane is 21, 25 times more lethal as far as the global warming potential is concerned compared to carbon dioxide. So if they can also capture methane, it will have a significant impact on the waste sector emissions. And when we talk of wastewater, so again, there are these different technologies which can be deployed in Indore, which are currently not there. For example, again, non-revenue water, that is very high in Indore. So this is one discrepancy which we observed. The Climate Smart Cities data assessment framework, which I talked about initially, in that, Indore has submitted that they have an NRW of 20%. Now, as per the benchmarks of Ministry of Urban Development at the Government of India, the 15% benchmark is there for non-revenue water. And they said that in a phased manner in the coming 5-10 years, we'll reach this benchmark. But when we actually consulted the officers and the departments in the corporation, we got to know that it is currently 67%. 67% of the water is being lost through leakages or through, water is, when there's a supply through tankers, again, there are leakages, all those things, which is huge. And it has a huge implication on emissions, specifically for Indore, because as you might be aware, Indore is pumping water from 80 kilometers away from Omkareshwar, right? The Narmada, different phases of the Narmada project, they are pumping from 70-80 kilometers away, they are pumping it upward. There's an elevation difference between Omkareshwar and Indore. So huge energy costs on one hand, huge emissions because that energy is coming from a grid which is not decarbonized, which is not green. So, again, a huge potential for reducing emissions. So based on this analysis, what we get to know is what are some of the areas which have the highest mitigation potential. Again, grid decarbonization is the first and foremost, because when we saw the first bar chart, we got to know that energy-related emissions are the highest. And how can you reduce those emissions? If you decarbonize your grid. Solar PV in residential, commercial and municipal buildings, passenger mode shift, etc., these were the major things which we have observed in the slide shell now. This is a slide shows a glimpse of what the national level targets look like based on the national analysis which we did, which I have not shown. If you recall the first slide, I said that this same thing has been done at the national level based on another model which WRI India has developed, the Energy Policy Simulator model. In that, there is a long-term decarbonization scenario supporting the India's 2070 net zero target. In that, there are these kind of targets which, if adopted, would lead to net zero 2070. As compared with that, if you see, for a few, there is a huge potential to shift. Four-wheelers, India has can take a target of 53% for achieving net zero. Indore 96%, Ujjain 80%, Surat 80%, Mumbai 96%. Why? The reason is that this is a very granular scale. If you want to, shift these from conventional to electric vehicles, there has to be, these, especially at the city level, it is also driven largely by consumer choices. As we are able to see, there are subsidies and enabling provisions coming up. So with these, these consumer choices are also being altered, and there are renewables which are being promoted a lot. But when we talk of the national level, there is a huge rural and suburban sector which is there, which cannot be, is not that easy to push, to move or switch towards cleaner fuels. If we talk of buses, again at the national level it's 43%, because that also includes a major part of rural and semi-urban. But in cities it is possible, supported by, of course, a push towards public transport, behavioral shifts, transit-oriented development, provision of non-motorized transport, all these things. What are some of the challenges and learnings which the cities can face while doing this analysis, or can learn from these analyses? There's a very limited data availability. So what needs to be done? Either city authorities can collaborate with academic institutions, with local think tanks, local civil society organizations, to have a repository of data. Data right now, again, it is being collected and stored in a very ad hoc fashion. That also, again, there's a challenge that cities, the ULBs, are a service delivery agency. They are not a planning and implementing agency, right? So they maintain that kind of data. And we, as academicians, as think tanks, have a responsibility to not further impose these kind of principles on them, that this is not the correct way. You should also have all these data sets which you should maintain, because that is not their mandate. They are already overburdened. So what can be done practically to support them is partnerships. They should partner with different institutions, which is now gradually picking up. A lot of city authorities are partnering, are valuing these partnerships, and then utilizing the data or the analysis. So data, of course, is one, and then capacity building on why this data is important, what you should do with this data, etc. So capacity building is also an important aspect. The second major challenge is synergies within city and within multiple governance levels. Within a city, we understand there are different departments, same as at the state level, same as at the national level, who do not converse with each other. So it is the responsibility of the leadership or the decision-making authority at the city level to bring all of them together, to break these silos. There is a comprehensive mobility plan which a city is developing. But is that comprehensive mobility plan also informing the master plan? If not, that is a big challenge. That shouldn't happen. So if there is a master plan being developed, is it being informed by the future demand and supply planning of the Water Resources Department? Because where will the supply come from? And if at all there are new developments which are proposed within the city. So there has to be a synergy, there has to be collaboration, and leadership is extremely important. And last, choosing the right tool. This is what I wanted to come to when I was talking about pathways and curve. So both these tools, what we observed while working on these was that they are not that suited to Indian conditions. In India, in Europe, if you put these tools to practice, they have all the data sets which are required for these tools. There are Excel sheets, and they have all those fields. The units which are there, they are not suited for Indian conditions. The emission factors are not Indian. So everything has to be customized. Will the cities have the capacity to do that? No, they won't. Here also partnerships becomes important. And again, limitations of the tool in terms of usability, in terms of restrictions, etc. What we did after this exercise, when we observed that these tools are not, we found it very difficult to work with them. How can we expect cities to do that? And these are not, the tier 1 cities we are talking about. These are Amrut cities now, where the action needs to happen and it has to aggregate. What we are doing is we are developing a tool suited for Indian conditions. It's still in pilot stage. All the formulae and everything have been entered. The user interface is ready. We are now pilot testing it across different geographies to validate it. So tools, choosing the right tool, and then building the capacity of the local stakeholders, not just government, but also think tanks, academic institutions, CSOs, etc., on how to use this tool so that they are actually present at the local level. They can support the local governments. So these are the challenges and learnings which come out from this exercise. And specifically when we talk of capacity building, what is required, and all this is happening now. Each of these are happening. Climate cell. It is very important that the cities should now start thinking of developing climate cells, formulating climate cells. In Bombay, based on our work, extensive work in Mumbai, we have developed the Mumbai Climate Action Plan, and we have been engaged with them since the past 5-6 years. They have constituted this climate cell. There is a dedicated, climate adaptation officer, climate mitigation officer, and then technical experts who are now being hired. Again, they are offering a fellowship, so that interested people can come in, join, contribute, and then learn and go back. So all these things are happening. It's very necessary to have an institutional framework at the city level which talks about climate change, which understands these issues. There's an institutional memory which needs to be created so that climate actions can be planned and implemented. City level data dashboards, this again comes from the earlier slide. If there can be a dashboard, like we have open data portal, data.gov, people should also have the functionality to submit the data which can be vetted and then hosted on this dashboard. All departments should have access to it. Whatever new they are doing or whatever new is happening, it can be fed into this dashboard, which can be used by anybody for analysis or for planning. Dynamic city level plans. Why do I say dynamic? Because again, what happens is if a city level plan or a state level plan is developed or formulated, it remains a static document. But circumstances change. Emissions are changing on a daily basis. So these plans, whatever they recommend, whatever they suggest, will also change. Today, there might not be a need, say in a city from Himachal Pradesh to focus on cooling. But maybe a decade after, cooling might become a substantial issue for them as well. So, there has to be a dynamic nature of these city level climate action plans. Monitoring, reporting and verification frameworks. It's always important to have a feedback mechanism. If you want to ensure that your plans are dynamic in nature, you need to measure what you are implementing. You need to measure the progress, or if the progress is not happening, so that it can give a feedback. And climate budget, where will the finance come from? Again, Mumbai is the first city to formulate a climate budget. What it does is that there is a budget of the corporation which comes up, which is placed in the mayor and council. In that, they identify which of these scheme codes in the budget are relevant to climate action and to what extent. Is there a possibility to increase allocation to these codes which are relevant from the climate action perspective and reduce the allocation from some of those which are not, or which are not that important. So basically, a city gets an understanding of what is the public money available with it for implementing climate actions, and how it can leverage that public money to raise in more private capital. So, as we said, climate action is possible only if private sector will come in, especially for countries like India. There is a huge requirement of climate finance, which the government doesn't have the resources for. Private sector has to come in. Now, what kind of instruments will that be? Will there be an equity consideration in that? Will it be debt? Will it be a complete grant? Maybe philanthropies and CSRs can come in. So what can be that? That is possible if the city has a climate budget, because this gives confidence to the private sector, the philanthropies and investors, that the city is serious about climate action implementation, and it is worthwhile to invest over here, right? Yeah.
There is a lot of contradictions on the climate budget and the budget allocated for the development of the city.
Yeah.
So the budget making agencies could not come to a conclusion how they should move, taking together all these things. So what is the way forward for these contradictions?
So the challenge again is capacity related. There are methodologies for doing the climate budget tagging. Now it is tagging, what I am saying, right? After the tagging, budget allocation will happen. What is tagging? As I said, there is a scheme code, say water supply. There is a scheme code for that. The corporation allocates 1,000 crores for that every year, right? Now we understand that water supply has a strong adaptation relevance. If you cut water, the population will lose its adaptive capacity. So you can, attach a high relevance to this particular code. Then there might be another code which says allocation of 500 crores for the current financial year for procuring diesel to operate the solid waste management fleet in the city. Now, this might be a low relevant or not at all relevant, right? So what the city can do is, if I can cut down this 500 crore to say 200 crore, move the 300 crore to other scheme codes which have a high relevance from the climate perspective, and यहाँ पे जो this reduction which has happened, I deploy electric, vehicles for solid waste management. There will be a capex, right? That we can manage. Say for the current year, we don't allocate this 300 crore. We use this 300 crore to get in these electric vehicles. From next year, we'll move this budget to that budget. But do the cities have an understanding of these kind of methodologies? No. So what we are doing in Mumbai, we extensively supported them for the first round of climate budget and building their capacities at the same time.
For these things, climate cell can be a very important
Yes, yes.
They will advise them how to channelize the
And the climate cell, the constitution of the climate cell, there will be of course technical people, but then it will have representation from all these departments, so that no one is left behind. All their views are there, and then there are technical people from the climate perspective who can suggest or advise that this is the alternate way in which it can be done, which will have more benefits rather than costs. So climate cell is the starting point.
So what you suggest that the climate budget percentage in the overall project total budget scenario, like that you are talking about the 500 crores any sewerage and water supply and solid waste management, such type of project, that is special purpose vehicle state government has created. So how much percentage should at the neck to neck or bottom line should be?
So there is
allocated?
no, I mean, it will be specific to every city. You cannot set a benchmark. For instance, we are working in Bihar. We have developed their long-term net zero strategy for all the sectors. Again, in intensive modeling exercise and engagement. Now we are engaged with them for finance, securing climate finance. And the first exercise which we are doing is this climate budget tagging, so that we know where the state stands. Now for a state like Bihar, which is disaster prone, which has very little potential to expand on renewable energy because it remains either flooded or submerged, 50%, more than 50% of the state, the entire northern Bihar remains submerged for 6 to 8 months. And the southern part is drought prone, right? So with such unique challenges, they have around 10 to 12% of their annual budget as green budget. Now they are, taking conscious decision to increase it in a phased manner. How? Again, reducing allocations from the non-important scheme codes to these important scheme codes. For a city like Mumbai, when we did the first climate budget tagging exercise, they have a climate budget of around 18%, 1/8, right? So it's different for different cities based on what they are currently doing, what is the priority for them, and what should be the priority for them. For some cities, water might emerge as the main priority, not renewables or these things, because they do not. For a city like Ujjain, say, very small population, very short distances, why would people prefer switching to public transport? If they have to travel 2 kilometers, there is no transit oriented development, there is no last mile connectivity, they will prefer to use their own vehicles. So these will not be economically feasible options for a city like Ujjain, unlike Mumbai, right? So they have to prioritize. Now what this exercise does enable you is identify those priority areas which are economically viable for me, and then you start allocating budgets and reducing from those which are non-priority. And through this exercise you can also set accountability, that in government progress is measured in 2 ways. One, how much spending you have done. 2, how much physical target achievement you have done. So if you have a target for both spending and physical, then your accountability will be set in that way. Are you able to spend, now earlier it was 500, now it is 800. Are you able to spend 800 crores? If not, then it will reduce in the next iteration, or you will be given a token cut in the budget. But then if you are able to do that, then you can ask for more, and eventually what is happening is this money is being spent for actual infrastructure creation, which is leading to building the resilience or reducing the emissions.
Sir, the Climate Smart City framework and this also mostly cover the economical and environmental aspect, but not the social aspect of the sustainability. So what all factors should be included, parameters should be included to cover that part also, so it's more equitable, and adding to that the budget. How do we ensure that the budget is equitably distributed and reaching the most vulnerable and most marginalized part?
Right. So this is where, so this was a mitigation related analysis. When you talk about equity and social considerations and justice, that comes in the other part, the adaptation and resilience part, where you have to identify which pockets are vulnerable in the city. So which wards or which zones are vulnerable or particularly vulnerable due to which impacts, right? There might be, an area which is very vulnerable or identified as a hotspot from the heat perspective. For instance, if we talk about Bhopal, say, this is hypothetical, E1, E2 Arera colony, they are identified through this analysis as hotspots for heat related impacts. But is it really vulnerable? Is the population that vulnerable? No, they are economically very well off. On the other hand, there might be a case that E1, E2 Arera colony might be identified as a hotspot because they are witnessing a temperature rise of say or 1.2 degrees Celsius, while a slum might be witnessing a temperature rise of say 0.6, 0.7 degrees Celsius, because of which it was not identified as a hotspot, right? But then they are vulnerable, they do not have the adaptive capacities. So where will you prioritize action? So this is the hotspot mapping, vulnerability and risk assessments, and then planning for those kind of things. Climate Smart Cities Assessment Framework, what it does is, as I said, the top 2 or 3 themes, they are mitigation oriented. The only theme, water and green cover, biodiversity and urban planning, that is what looks at both. So green spaces, blue spaces, how should the city develop, and all these things are in one thematic area. Water, so reduction in non-revenue water and efficiency in water pumping and water supply, etc. That again has energy related implications. But then these are the 2 sectors, so very limited in scope. But when I'm saying this climate cell, they need to have these kind of experts. There has to be a gender expert, there has to be a social safeguard specialist. At the national level, there is a program called CITIS, CITIIS, City Investments to Innovate, Integrate and Sustain. Mahua is anchoring that program. We were a part of the design of that program. So there was a consortium, WRI India. It is funded by European Union, AFD, which is the French funding arm, and the KfW, which is the German bank. So these 3 are the funding, and then there is a Government of India contribution as well. They provide support to the cities and the states. That again driven by a challenge process. They invite proposals and then select. But in that, they have these gender experts or specialists, social safeguard specialists, ESG specialists. All these are there at the national level, and also a requirement for cities to engage these kind of experts or specialists if they are selected for the challenge. Because there is a funding grant support of 100 to 125 crore rupees which will be given to cities. So they have to ensure that these implications are addressed in the project implementation. So there are things which are being discussed, which are being done. Again, how much awareness is there is the challenge. At the city level, it's very, varied, I would say. I won't say it's not at all there, it's varied. This is where partnerships and engagements are important.
Just a last one, you mentioned that in your view, on the sector of waste management, they are not doing much.
No, they are doing a lot. I said they are doing a lot. But then there is also a scope, though it is very limited as compared with other sectors. When we looked at the emissions, the pie chart, as compared with other sectors, and in the overall kitty, solid waste management is just 1%. Wastewater is around 8 to 10%. Again, why wastewater is 8 to 10%? Because of the gas not being captured in the STPs. There is scope, but very limited, because Indore is already doing a lot in waste management.
That is what I'm
Yeah.
So under smart city mission, integrated credit, carbon credit market also, they are the leaders.
Yes. So
is WRI is working with, is anyways engaged with them, or is?
So we are working with Indore since a long time. Right now, the priority for Indore is air quality. So we are working on apportionment studies and identifying again sources and hotspots and fuel switching in the MSME sector, or energy efficiencies or adoption of new technologies. So these are some of the areas where we are working with Indore. Okay, thank you so much. It was a pleasure interacting with you all, and ma'am has my contact details. Ma'am, you can share with them. Anytime you need any kind of clarifications or support, I would be happy to.
I think there are many questions, but due to time limitation, we'll be approaching you here.
Sure. Thank you so much.
I would now request Dr. Surya Niratra to felicitate Mrs.
for delivering this talk. Thank you, sir. This is
Thank you so much. Thank you so much.
Yes. Okay, good afternoon everyone. So today we will start with another, in continuation with my previous lecture, that we are talking about urban areas, and urban areas, the inferences we had from urban areas, and when we are talking about urban heat islands, then the urban areas are not, first thing was not uniform all over the urban areas, right. They have different areas, have different contribution to urban heat island, simply because urban areas are made up of a lot of different type of surfaces. The canopy also changes from place to place. The typology of them also changes from one area to another area, and there are many. We talk about our Indian city, they are having heterogeneous form, and when we talk about heterogeneous form, means form changes, small distance itself we see change very much. So you will find high rise buildings, and then to it you will find slum areas which will have a very contrasting typology. Became very important for us to as a scientist, as a researchers, to understand what kind of form is suitable for us. So for reducing our heat island effect, what should be the constituent of these areas, because we all know there are built surfaces, there are buildings, there are pavements, there are vegetations. So what should be that combination of components in that urban ecosystem that we need to analyze. So to start with, there was a system which is very recent, which is called as local climate zone classification, and this system was actually very recent. It is proposed by Stewart in 2012, and as per the basic classification scheme, what they did was they simply they did not look only on the buildings, but also what kind of vegetation is. So if you will look outside the buildings of Manette, so you will see there is G plus 2 floors, but some sparse vegetation here and there. And then if you go to say Newmarket area, you will find buildings and no trees at all. So that form is completely different. And if you go to another areas, if you have seen slum areas, definitely we all have seen what are the slums. So in slum areas you will find closely packed low rise houses with very sparse or completely no vegetation. So that was a inquiry or an hypothesis. With this it was started. There are different forms. Can we classify these forms into different classifications? And apart from the buildings, we have to look into their forms, their heights, and also what kind of vegetation is there between those areas. Because till now all the research which was going on was on surfaces. What is vegetation and all, what is the percentage of land which is covered, which is paved, how much is the built area, what is the fraction of built area. So it was all till then talking about only the surface fractions. Of course that also has a contribution, but then we thought of, and after Stewart we started thinking about the 3-dimensional form of the building, which also contributes to the near surface air temperature, or at the canopy level, the form becomes an important characteristic. So this is the basic classification, in which there were 17 standard local climate zones which are classified. So you can see there are compact high rises. So in India it is very less, that we have only compact areas with high rises. So, maybe in Mumbai or now in Bangalore, Hyderabad, you will find some core area or CBD areas where there are compact high rises. Then compact mid rises very commonly found in India. Our FSI, our regulations results into such kind of compact mid rise form. So, in Bhopal you will see this is the form which is most prevalent, and more so it is compact low rise form everywhere. The reason, because there are many reasons behind it, because it is mainly the capital city, it has lot of government housing. So, there is ample land available. So, there are many bungalows, independent houses. So, it is open low rise characteristics which we see nearby. So, we will see small houses with G+1 with lot of vegetations near all around. Even if when we will go to Manit campus and we will see the housing of faculty, we will see mostly these are open low rise or mid rise housing. Then if we try to categorize how are the slums, you will see generally they are lightweight low rise. So, this was added later on because only compact low rise was not categorizing the slum areas, because they had very light roof, they had tin roofs. So, that was then it was categorized into lightweight low rise kind of housing. And so, this was there are many classification, even the industries were classified, and the main purpose of this classification was, as we can see, this is local climate zones. So, it indicates that these areas have a local climate formation or microclimate which is different from each other. So, if we are taking the measurements in these areas or air temperature in LCZ1, it will be different from LCZ7. So, that is what we are looking into, why it is so, what is that particular, and even if it is different, it does not stop here. What should be the ideal height, density, form, compactness that we should adopt to have a like to mitigate the heat stress or heat island effect in at human scale. So, now categorizing a long press. Okay. When we are categorizing these LCZ, how did we start it? Because there are many parameters. So, we can just visually see that we were talking about the building height, mean height and aspect ratio. What is the height by divided by the width of or the distance between the two buildings, that is what is aspect ratio. But then we in this classification we have also added or they have also added sky view factor, terrain roughness, fractions, pervious surface fractions, sorry this is fraction, and impervious surface fraction, friction, because it is also we have to see how much is the urban area, what is the patch of urban areas, surface admittance and albedo. So, these are the various parameters which were used to actually classify or create LCZ classification. So, I will quickly, we all mostly know what are these parameters and how are the classification done, but sky view factor, as sir has already explained, that it is the openness between the buildings. So, it is ranging from 0 to 1, aspect ratio is height to width ratio, and this is very important, because when we are talking on practical now field, when we talk about, because it is not just on paper, we have to be also checking with the local building bylaws, what are the bylaws saying, because it is not, this is not a current science, they based on our studies which are done previously also, the bylaws, building bylaws are made, and building bylaws have been made to consider enough daylight, enough airflow in within an area, and for that a particular kind of particular aspect ratio was defined, that this much should be the setback, the building should be this much away from the roads, so that a particular aspect ratio can be reached, and that could be an aspect ratio which will give enough light and ventilation to a building or building typology. So, now we are questioning what it is not just 1/3 aspect ratio that will work. We have to look in beyond just classifying the height and width ratio. We have to see what kind of trees are there, what are the surrounding buildings, what is the impact of other forms on these areas. Then mean building height is just the height which is for an area. Roughness class is again what is the roughness, how much what are the height of the building and what kind of roughness they are creating on the surface is the roughness, to what extent. So, that is the roughness class. Then building surface fraction. So, when we look in plan, we see how much, what is the area which is being covered by building in a particular plot size. So, that also matters, because how much ground surface is open to sky and how much is covered by buildings. So, that is what actually decides what is the reflectivity, flow regimes, heat dispersion from the ground, etc., and it is the percentage that we look into. What is the surface fraction? Then impervious fraction again is the same thing, how much area is impervious in nature and how much it is open to sky, and not also for water we see how much pervious a surface is, what is the moisture availability, and also the heating and cooling potential of an area. Pervious fraction, surface admittance is actually what kind of surface it is, whether it is soil, water, etc. Then albedo, as sir has already explained, the surface reflectance at a particular scale. Then yeah, so these are the different types of LCZs that we have classified, and this talks about compactness, compact, high, rise. So, now here we are clearly talking about how close are buildings and how high are buildings. So, we can see a compact high rise may be very different from say a lightweight low rise building. So, this is our hypothesis, and let us go and see how what kind of results we are getting. So, if you look into just simply what kind of compact high rise is, we can just go a different type of classification in actually. So, it is just an illustrative picture how a form is and how on ground it looks like. Okay. So, after this this is the tutorial which we will be doing for Bhopal tomorrow, because today we will go for observations. So, how to categorize this on for a particular city, how to create a scheme following the scheme, that we will do tomorrow. This is generally the types, and sorry, samples, training samples, that we will do tomorrow. Now, this is what we have done for collecting or training samples from Bhopal. So, this is Bhopal planning boundary. So, we restricted ourselves to the planning boundary of not planning, this is Bhopal Municipal Corporation area that we are taking different wards, and then these colors show different types of LCZs that we have seen. So, that we have identified, verified on ground, and then classified into different local climate zones. So, you can see this is dominant one, that is compact mid-rise typology of LCZ throughout the Bhopal, and you can also think about like we have similar kind of typology, and this is open mid-rise, right? Yes, actually this study was focused only on the housing typologies. So, we restricted to housing, but water body will come under one kind of LCZs. So, these are from Bhopal itself, these pictures are from Bhopal, compact mid-rise. So, nowadays we see that row housing is very much into usable and also very much prominent in common in Bhopal and many other cities also, because it gives independent bungalow type typologies, and so this is compact mid-rise. So, most of the developers go for compact mid-rise nowadays in Bhopal. So, this is compact mid-rise LCZ2. Compact low-rise is again, I would say, the sorry, old city areas, the core areas which were compact, and that is also was regulated through our bylaws. So, at that time the old city area did not have any regulations. So, it was compactly built, and they as much as space they got, they have built it. So, it became compact and it was low. Then open mid-rise. So, open mid-rise is mostly the government houses and the bungalows which are now sanctioned with a particular MOS to be left, how much is the FSI, G, and mostly it is G+1 and open mid-rise typologies that we see. And open rise are generally also, but they are in very less numbers. Then light housing is again slum housing, and large low rise are industrial areas, PHL and other areas are low rise. Sparsely built is again the farmhouses and the bungalows which are there all over Bhopal. Okay, so after this, this is the complete local climate zone map of Bhopal, where you can see that mostly this compact low rise, this is the old Bhopal area. Then these are slum areas where you can see open low rise, open low rise are the government housing areas, large low rise are 8 are the industrial areas, etc. So, these are the prominent one which we saw in Bhopal. This is Bhopal planning area. This was in 1990, when the development has just started around Bhopal, and we saw the urban core areas or the city areas, now it is called old city, where this was compact low rise development. Now, with over the 20-30 years, if we see 2020, we have seen this is the kind of development we are having, where mostly it is compact low rise. Then now this is again we are seeing large low rise, open rise which are spread, and this is sparsely built areas, that is on the fringe areas, and we will see compact low rise and open low rise, large low rise areas also here in between. So, this is what is the typology now and classification. And if we see into the surface temperature, we can actually relate where the temperatures are high and low looking at the LCZ. So, this is the research paper with Rakesh, and it is there on site, and we can see whether what kind of LCZ has what kind of land surface temperatures. Okay. And this is the LCZ classification which is prominent in Bhopal, and we can see the area under LCZ D is 38 is water, I guess, agriculture area, and this is agriculture area which is around Bhopal in the whole planning area, because we are taking, and then rest is LCZ, you can see 6 as 2.8, 9, all these are the areas which are prominent in Bhopal. Now, what we will do in our exercise is, we will try to find out those locations where before this, can you put up the another presentation? दूसरा presentation लगा दीजिए. Yes. Okay. So, keeping in mind what kind of geometry we have to see. So, whether there is variation in building density, height, size, which is again we reflected into land our local climate zone classification. Then what kind of activities, whether it is residential or industrial, that we have to see. Then what kind of building and material it is. So, that again is again a parameter that we have to look into. Then water and vegetation. So, all these things are actually we are trying to capture in our LCZ also. So, these are being considered in our LCZ, and if I have showed you in my presentation, yeah, this is what like there are different processes, different surfaces, and together they form a urban ecosystem or LCZ that we are seeing. So, because there is a particular sun power, there is a wind flow, and all together they will categorize what kind of microclimate we have in an area. And using this only we had I have in my study categorized into forms. So, whether what kind of vegetation is here, what kind of built is there, water is there or not, and this is how we can categorize the forms in our areas. So, same way if we go into our areas, what we will do is we will go to our selected sites and we will do such kind of sensor based studies in different areas. We will take the recordings, air temperature, relative humidity, wind speed and globe temperature, and we will try to capture. I will ask you all to just note down what is these parameters in a particular location. So, we will ask you to write location 1, location 2, we will just go to for 4 locations, and each location you have to note down these parameters, and then we will come back and see what are those, whether there are differences in these TA, RH, wind speed and globe temperature. So, that we will aim for. So, but as you must have seen in the yesterday's tutorial, we need lot of data to for our creating our evidence, and we are just going to tell you how the observations are taking. So, one reading is never enough. We have to do it multiple times and then we have to do statistically prove that whether there is a relationship between the comfort or not. So, these are the parameters, and what we are aiming is, or these are our independent parameters, and our dependent parameter is whether we can take it land surface temperature, any thermal profile component. So, it could be land surface temperature, what is the temperature, or we can take human heat stress, human comfort indices like heat stress, humidex, there are many indexes, and we will try to relate it with that, and we can assume that at 30 degrees or 30 degrees as a human we feel normal during a particular season, and if it is going more than that or less than that, then there is a variation in the comfort level. So, that way we will check what is the situation, whether how much it is deviating from the mean areas. Okay. So, now we will go and just see how we are getting. Okay. So, going back, let us just close this and then put the previous slide, previous presentation. पहला वाला yes, yeah, this is good. Okay, so this is Manet, our campus. We are here, this courtyard, and what we will do is we will start taking reading. These are the civil department, mechanical, and the 4 building areas. So, they mostly these are paved. So, we will try to take one reading here, because this has a particular type of urban form which is devoid of major vegetation. It is all paved, it has a particular height. So, we will take one reading here, then we will go to nearby this lake. This is a small water body. So, we will go and take the observations here. Then we will go to these faculty house, faculty accommodations. So, we will go and take here, this here,
Behind top and town.
I think here, yeah, this area. And if we have time, if time permits, this is a very typical form of slum areas which is very close within this area. So, these are the slum areas you can see. So, we can go here and take readings, and these are slum rehabilitation authority areas. So, these are G+4. So, there is very good contrast. These are very, here the aspect ratio is very less. They have lot of shading here, they have rises, but these are compact but open and low rise. So, this is very different type of LCZ that we can see. So, we can go here, here. So, bus can go till here, we will have to walk this place and take the readings. And this area is again row houses, row housing, which we said was LCZ 3. It is compact mid-rise housing. So, but it has lot of vegetation, and again, so we will see how much time we had. We will try to take 4 points, 1, 2, 3 and 4 here. Okay. So, clear, any doubts? No? We will go and take recordings or take the observations and then come back and analyze it. Okay. रिकॉर्डिंग लेंगे वहाँ पे. So, before that we will just go and see the equipment.